All right, guys. So what we're going to do today is you guys are going to do your single replacement lab. And then once you put your metals in the solution, they have to sit there for the remainder of the class period. And that gets a little boring. So after I explain to you the single replacement lab, making sure you guys understand what to do, you're going to go to the lab, put your metals in the test tubes, and then you're actually going to come back and watch the rest of the Schoology lesson because I'm going to go over your chemistry of the week. All right, so for your lab, what you guys are going to be doing is, remember, Anthony, your table, you're going to take pieces of magnesium metal, which the wayboats are labeled. So this is your magnesium metal. You're going to take one piece of this and you're going to put it in one test tube. So one piece of metal per test tube, one piece of magnesium metal per test tube. And then in the first test tube, you're going to add the magnesium solution. So the magnesium solution is labeled, it's clear. So in the first test tube, you're going to put about 3 pipettes worth of liquid in that first test tube. Then you're going to take the zinc and put about 3 pipettes full in the second test tube. And then the iron in the third test tube, about 3 pipettes full. And then the last test tube should have about 3 pipettes full of copper. So Anthony, your table is doing the magnesium. So magnesium in all 4 test tubes. You're also doing copper. So you're going to get another set of test tubes and you're going to put all 4 pieces of copper like in each test tube. Arabella, you're doing zinc. So 1 piece of zinc in every test tube. Mason, your table is doing iron, 1 piece of iron in every test tube. And then every group should have about 3 pipettes of the magnesium nitrate in the first test tube, about 3 pipettes of the zinc in each test in the second test tube, about 3 pipettes of the iron in the third test tube, and then the copper, about 3 pipettes in the fourth test tube. Now, once everybody takes their 3 pipettes, if you need to add a little bit more liquid to that test tube in order to get this, the metal completely covered, then you can do that. It honestly doesn't matter how much liquid is in there, so long as the metal is completely submerged in the liquid, okay? So once you do that, record what everything looks like in the beginning, maybe even take a picture. Once you do all of that, then come on back. So like pause the video now. After you do your lab, come back and we'll talk about your chemistry of the week. All right, so now that you guys have started your lab, we're going to be waiting a few minutes for those chemical reactions to take place. So go ahead and get out your chemistry of the week too. Once we're done going over this, you're actually going to turn this into bin. So for the first one, we're looking for the formation of methane. So you may not know what methane is, but you can figure that out from what's given to you. So like, you know, that's carbon, you know, that's oxygen, you know, that's carbon dioxide, hydrogen, oxygen, water. Don't know what that is, oxygen, carbon dioxide, and water. So that must be methane. So if we're trying to form methane, what we need to do is we need to flip this bottom equation so that methane is a product. So whenever you flip a equation, you change the sign from negative to positive. So this is what we got. So now we need to get everything else canceled. So if once I flip the equation, this bottom equation, once I flip it, oxygen is a product, carbon dioxide a reactant, water a reactant. So here I see carbon dioxide as a product that needs to cancel with my reactant. So I'm going to leave that one alone. For my water, I need to cancel it It's a reactant in the bottom equation once I flip it. So this can stay the same, but I need to cancel 2 moles of it. So I need to multiply this equation by 2. So once I do that, I just find the one that matches up when you add everything together. So this stays the same. Here we've multiplied it by 2. And here I flip the equation so the sign becomes positive. So D is your answer. For question number 2, which one describes heat? I bet a bunch of you put B, but actually that describes temperature. So C is your answer. For this one, we're trying to find the initial rate of the reaction from the graph. So you could take a ruler and you're going to draw, this is initial, so at time 0. So we're going to draw from here down, and we see it's somewhere around here. Yours may have crossed here, or maybe even a little further over here. That's fine. But then you take your change in concentration, which is 1.6, divided by your change in time. So like your run from 0 to here, which is about 8. So 1.6 divided by 8 gets you around 0.2. All right, for question 4, we're looking for an increase in the rate. So that would be an increase in temperature, but a decrease in particle size. All right, so now we're trying to calculate the amount of sulfur dioxide produced when this undergoes combustion. Hold on, I think I may have made a mistake. All right, so here we have our chemical reaction equation, and there's my sulfur dioxide that I need, but I'm only given information about lignite. So I take my grams of lignite, I multiply it by the percent of sulfur. So to get this out of a percent, I need to divide by 100 in order to get that to be my decimal. So I take my mass of my lignite, multiply it by 0.004 to figure out how many grams of sulfur are present. Then I take my molar mass from my periodic table to convert to moles of sulfur. So once I know my moles of sulfur, then I can use my mole ratio, which it's a 1-to-1 mole ratio. So that gives me 0.062 moles of sulfur dioxide present. For part B, it says write an equation that shows how sulfur dioxide can produce acid rain. Here's sulfur dioxide reacting with water to produce sulfuric acid. Sorry, that's a little squished. All right. Okay, so then on the next page, hey, this should look familiar. This whole thing probably sounds familiar. So list 2 variables other than concentration. You could say temperature, you could say pressure, you could say particle size, things of that nature. For D, it says discuss 2 ways to reduce the environmental impact. You can remove the sulfur from coal. And then also another one too would be to not allow the sulfur dioxides or sulfur oxides to be released into the atmosphere. All right, so that's your chemistry of the week 2. Make sure you turn that into the bin. And now you guys can go back over to your lab stations and check on the progress of your reactions. Be sure to note any changes, feel the outside of the test tube. Some of them could be getting a little warm or a little cool. Maybe take a picture if you want. And also don't forget to go look at the other people's test tubes as well, because at the end of the day, when you write your lab report, you're going to need to have the complete data table filled out for all 4 sets of test tubes. as well as qualitative data for all 4 sets of test tubes. And then also, when you look in your lab procedures where it says conclusion, you'll have to write the half equations and full balanced equations for all the reactions that occur, not just the ones in your test tube, but in all 4 sets of test tubes. Okay. All right, so go do that and then wait until the end of the class period to look at observations again. And then when you're finished, take everything that's in your little test tubes and pour them into the giant waste container. Okay? Cool. Have a great weekend, guys. Work on your 3rd chemistry of the week. Make sure the sub gives you that one, okay? All righty. See you Tuesday. Don't come to school on Monday.